Hi, this is Cameron, and for my puff-up boat lab experiment, I decided to see if my puff-up boat's straw length would affect the rate at which water is pumped out of the puff-up boat. This is measured in hertz. I couldn't use the normal straw length, however, and had to opt in for a much longer 13-inch straw. This would allow for more tests and allowed for more extreme examples. The straw length includes the straw that is in the boiler. For my test, I recorded the popping sound made by the boiler when it was heated on my iPhone. This was recorded in MOV video files. I would make sure to get an 8-second long video, clear of any loud noises such as voices or popping. After I did one test and knew it was successful, I would cut 1 inch off the end of the straw and continue with another test. I did this 9 more times, starting with 13 inches and ending up with 5 at the very end. After getting 9 successful tests, I took my phone and converted the video files, the MOVs, into WAVs. These are audio files. The important part about these audio files is I could view them in a program called Audacity. Audacity allows the viewing of WAV files and allows me to count the separate blips, which are the separate pops made by the boiler. I would first count all the blips within a 3-second period. This would be determined by the clearest part in the 8-second long video, and then dividing that period by 3. This would be my hertz rate. What I assumed before looking at Audacity was that my rate was going to be linear, going up steadily as straw length decreased, as I assumed a shorter straw would mean a faster rate. What I discovered was, for most straw lengths, from 7 inches to 13 inches, the hertz rate remained fairly consistent in my Audacity testing. What was different though was my 5 and 6 inch test, which did show a great increase in the hertz rate. The only issue was, during these tests, the engine barely worked and the puff-up boat hardly moved. I would not consider these to be adequate tests of a working boiler, but they are still to be considered. Based on this, and based on the numbers I got, as you can see here, the average number was around 7 regardless of a reasonable straw length, excluding any extremes. This meant that, for the most part, straw length did not affect hertz. It did fluctuate up and down, but I would assume this would be to the engine bumping into something or obscurities in my sound testing. So, in conclusion, after testing the video files and viewing them in Audacity, I determined that the puff-up boat's straw length is not an adequate change in the hertz rate for a puff-up boat, except in extreme examples.